Hello and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 7.4C Language Part 2. Please like, subscribe, and hit the notification bell. Now let's run into the first topic, right after this short break. Declaring variables. A variable represents a numeric or string value. For example, you can solve x plus y equals z if you know two of the variable values. In programming, you can declare variables at the beginning of a program so that calculations can be carried out without user intervention. A variable might be defined as a character or characters, such as letters of the alphabet, or it can be assigned a numeric value, as in the expression int x equals 1. Here are some variable types used in C. Int. Use this variable type for an integer, positive or negative number. Float. This variable type is for a real number that includes a decimal point, such as 1.299999. Double. Use this variable type for a double precision floating point number. Char. This variable type holds the value of a single letter. String. This variable type holds the value of multiple characters or words. Const. A constant variable is created to hold a value that doesn't change for the duration of your program. For example, you can create a constant variable called tax and give it a specific value, const tax equals .085. If this variable is used in areas of the program that calculate total costs after adding an 8.5% tax, it's easier to change the constant value to a different number if the tax rate changes, instead of changing every occurrence of 8.5% to 8.6%. Now let's flow into the next topic, right after this short break. Conversion specifiers. If the printf function contains values other than a quoted sentence, such as numbers, you need to use conversion specifiers. A conversion specifier tells the compiler how to convert the value in a function. For example, print, your name is %s, name, displays the following if you have assigned the value Sue to the string variable called name, your name is Sue. Here are some conversion specifiers in C. %C, character, %D, decimal number, %F, floating decimal or double number, %SS, character string. Now let's groove into the next topic, right after this short break. Mathematical operators in C. In addition to conversion specifiers, programmers use operators to compare values, perform mathematical calculations, and the like. Most likely, programs you write will require calculating values based on mathematical operations. In addition to conversion specifiers, programmers use operators to compare values, perform mathematical calculations, and the like. Most likely, programs you write will require calculating values based on mathematical operations, such as addition or subtraction. Here are the mathematical operators in C. Binary. Doesn't change the value of the number. Unary operators use a single argument. Binary operators use two arguments. Example, +2, ++ unary, increments the unary value by 1. For example, if a is equal to 5, ++ a changes the value to 6. Unary, decrements the unary value by 1. For example, if a is equal to 5, a changes the value to 4. Binary. Addition, for example, a plus b, binary subtraction. For example, ab, binary multiplication. For example, a *b, binary division. For example, a/b % binary modulus. For example, 10% 3 is equal to 1 because 10 divided by 3 leaves a remainder of 1. Now let's jump into the next topic, right after this short break. You might also need to test whether a condition is true or false when writing a C program. To do that, you need to understand how to use relational and logical operators, which we will show next. Equals equals equal operator compares the equality of two variables. In a equal sign b, for example, the condition is true if variable a is equal to variable b. Equal sign not equal. The exclamation mark negates the equal sign. For example, the statement if a equals b is read as if a is not equal to b. Vertical bar is the OR operator. Evaluates as true if either side of the operator is true. Is the not operator. The statement a equals b, for example, evaluates as true if a isn't equal to b. Using compound assignment operators as a shorthand method, you can perform more complex operations with fewer lines of code. For example, total salary plus 5 is a shorter way of writing total salary equals sign total salary plus 5. Similarly, total salary equals sign 5 means the total salary variable now contains the value total salary 5. Although this module covers only the most basic elements of a program, with what you have learned so far, you can write a C program that displays something on screen. Security testers should gain additional programming skills so that they can develop tools for performing specific tasks, as you see in Understanding Perl and Understanding Python later in this module. So now you know about relational and logical operators in C. Now let's fall into the next topic, right after this short break. Mistakes made by beginners. Many beginning C programmers make the mistake of using a single equal sign instead of the double equal sign when attempting to test the value of a variable. A single equal sign, the assignment operator, is used to assign a value to a variable. For example, a equals sign 5 assigns the value 5 to the variable a. To test the value of variable a, you can use the statement if a equals sign 5. If you mistakenly write the statement as if a equals sign 5, the value 5 is assigned to the variable a, and then the statement is evaluated as true. This happens because any value not equal to 0 is evaluated as true, and a 0 value is evaluated as false. So now that you heard that, hopefully you won't fall victim to these mistakes. Now let's dive into the next topic, right after this short break. Branching, looping, and testing in C. Branching in C is as easy as placing a function in your program followed by a semicolon. The following C code does nothing, but it shows you how to begin writing a program that can be developed later. For example, in the following code, the prompt statement, indicated by the semicolon at the end, at the beginning branches to go to the prompt function. When the program runs, it branches to the prompt function and then continues branching to the functions listed subsequently. By creating a program in this fashion, you can develop each function or module one at a time. You can also delegate writing other functions to people with more experience in certain areas. For example, you can have a math wizard write the calculate function if math isn't your forte. C has several methods for looping. The while loop is one way of having your program repeat an action a certain number of times. It checks whether a condition is true and then continues looping until the condition becomes false. Look at the following example, with the important code bolded, and see whether you can understand what the program is doing. Figure 7. 1 shows the output of this program. In this example, when the counter variable is greater than 10, the while loop stops processing, which causes printl to display 10 lines of output before stopping. Now let's flip into the next topic, right after this short break. More branching, looping, and testing in C. A do loop performs an action first and then tests to see whether the action should continue to occur. In the following example, the do loop performs the print function first and then checks whether a condition is true. Which is better to use, the while loop or the do loop? It depends. The while loop might never execute if a condition isn't met. A do loop always executes at least once. The last loop type in C is the for loop, one of C's most interesting pieces of code. A for loop starts with the keyword for, followed by 3 items in starting and ending round brackets, also called parentheses. There you have it, branching, looping, and testing in C. A for loop starts with the keyword for, followed by 3 items in starting and ending round brackets, also called parentheses. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.